So the last slide in 8.3 is when you're taking a complex number in trig form and you're raising it to a higher power. And it's just a matter of plugging it into the formula. You need to understand how to read the formula. The left side is showing you that a complex number in trig form is being raised to the nth power. The right side is the actual formula. Okay? So some people look at this and they're like, I don't really know what I'm looking at. Where's the formula? The formula's on the right side. If you have a highlighter, it might be helpful to highlight that this is saying it's raised to a power. So in terms of the formula, it's r to that power. Then it's that power times the angle. So this is the actual formula right here. No, you don't have to memorize it. It'll be given to you. How do you know when to use it? Well, if you look at the left side, you can see that it's a trig format raised to the nth power. That's how you know when you use it. So look at example 1. 1 plus I raised to the 9th. Notice in the formula it starts out in trig form. Notice here this is not trig form, this is a complex number. So this is where you would have to find, don't do it though because we've already found it, but this is where you would find A, B, plug them into the formula for R, then set up your cosine and sine, you get A over R, B over R, get your fractions, ask yourself where on the unit circle that coordinate point is, and get your theta. We've already done that with 1 plus I multiple times in our notes. So I'm going to come over here and make a note that when we did this, in a previous slide, we found r to be square root 2, and we found the trig formula, trig notation of that complex number to be root 2 cosine 45 plus I sine 45. Now that's the trig notation. Notice it's being raised to the 9th power. So I'm going to put really big brackets right here and show myself that I'm raising that to the 9th power. And then now I'm going to apply the formula. So the formula says, once you have it in trig form to a power, it's going to be r, which in my case is root 2, to that power, right? Parentheses, and you don't have to put the parentheses around the root. If you want to, you can. If it's too much, and you wrote it like this, it means the same thing. So you don't want all those extra parentheses. All right, and then parentheses, cosine, the power times theta, plus I sine power times theta. Okay, now we've got some things to clean up. We have the square root of 2 raised to the 9th power that we need to clean up. We also have, we also have 9 times 45 that we need to clean up. So go to your calculator. If you enter square root 2 to the 9th power in your calculator, you're going to get a decimal. And they don't want decimal form, although it doesn't specify right here, because Aiden was just asking me for help on a problem. The My Math Lab wants it in radical form. So let me show you that, not squared, hold on. To raise it to a higher power, you can type the radical come out of the radical, hit the math button. Not the math button, I'm sorry, I'm thinking of rooting. Hit the caret button right here. You see this? Looks like the rooftop of a house. That's called caret, which means whatever comes after it's going to go in superscript exponent position, and you can raise it to the ninth. But you're going to see that you get a decimal. They don't want a decimal. When you have a radical raised to a power, split it into the radical raised to 1, if it's odd, and then the radical raised to an even. So let me show you. Square root of 2 raised to the ninth. That, because that's odd, I'm going to make a note, because this is odd, my calculator is going to give me a decimal. Okay, so I'm going to split it into square root of 2 raised to the 8th times square root of 2 raised to the 1st. So I'm pulling 1 out, so now it's even. And then type in your calculator square root 2 caret 8. And it's pretty. And then just don't forget, though, that there's a square root of 2 after it that we didn't deal with, right? Right here. That's square root of 2. So the square root of 2 to the ninth power becomes 16 root 2. And if you're worried that you've done it wrong, the nice thing is you can type 16 root 2 in your calculator and confirm that you get the same decimal as when you typed the whole daggum thing in. Right? So this becomes 16 root 2. Um, 9 times 45 is 405. Is beyond full rotation, so let's calibrate it by finding the reference angle, and what is it? 40? Oh, 45? So I'm going to rewrite this whole thing, but instead of 405, I'm going to write cosine 45. Now, at one point in my math lab, this is where they want you to stop, because they have a format where you just fill in the blanks. Like it has a blank box for this front coefficient, and then it has cosine typed, and then it has a box for the theta, and then it has sine typed and a box for theta. So number 14 in the homework, this is as far as you go. But then I think on 15, they want you to go further, which just means because the angle that you have is on the unit circle, they want you to actually replace that cosine and sine with those fractions. Which you should be able to do this one in your head. 45 is that quadrant 1 where x and y match. So I'm going to replace this with the root 2 over 2. Oh, I wrote sine. And because these numbers are all even and all pretty, this will keep going. So we want to multiply the 16 root 2 in here. So we have just a plain complex number. These numbers end up working out nicely, so that's why all of a sudden what you see is really ugly is fixing to turn pretty. Right here, don't overthink this. This is 16 root 2 over an understood 1. Multiplied to the fraction root 2 over 2. So you just multiply straight across. If you understand what's going to happen here, you could, this is what I do, I say to myself, well, that denominator goes nicely into that coefficient, leaving me with an 8. So when I write it on my paper, I say to myself, okay, that 2 would divide into the 16 and leave me with 8, and then root 2 times root 2 is root 4. What? yeah, no, I just, yeah, which we keep going, but I want people to know where I got a 2 from. So that would actually be 8 times 2, which is 16. But then this over here, so repeat, the denominator divides into the coefficient nicely as an 8, and you'd end up with 8 root 4, which once again is, and now I'm going to shove the I to the end, which is 16I. Y'all see how I got that? I think on number 15 in the homework, they want you to go that far. You didn't have to do the little whole, like, dividing in your head or cleaning it up as you go. If you had not, I'm going to put 4. What if you just multiplied straight across and then cleaned up the mess you have? Okay, so it would be 16 root 4 over 2 plus I. 16 root 4 all over 2. And then you would see that the 2's divide into the 16's to give you 8. Root 4 becomes 2, and you would still get the same answer. B. Thankfully, these numbers are ugly, so it doesn't go as far. So let's do B if you have any room left at all to write it. I'm going to have to erase mine because I've obviously got no room. Are y'all good with that? So I think we found the complex number already for B. In a previous, if you find it in there. It's good practice. It's no big deal. You found it from example 3B. Let's see. Yeah, 3B. Root 3 minus I. Is it also in example 6? I might have pulled it again for another problem. Yeah. So this trig form is 2 parentheses cosine 330 plus I sine 330. Okay, and I'm raising that to the 10th power. So plug it into the formula. R goes to the power. And then the angle multiplies by the power. Now you can probably see where I was saying these numbers are ugly. 2 to the 10th power is 1024. And then, of course, here you're just tacking on a 0. And that is way too big to pull the trig function. So you would go to your calculator, and instead of sitting here, let's think smarter, not harder. Instead of sitting here and doing 3,300 minus 360, minus 360, minus 360, don't do that. Because clearly you know that this is like a ton of rotations, right? So what you could do is, you could say, what is 3,330 divided by 360? And you see that it can go 9 complete times. So now I'm going to do 3,330, or 300, sorry, minus 9 times 360. And now I can immediately get it right there in a range from 0 to 360. Now, you don't have to do that. You can sit there and just keep subtracting 360 until you hit a number between 0 and 360. But if it's a gigantic number and you just divide by 360 and take the whole part, that's letting you know how many rotations you can take off. So I'm going to rewrite this. What was it, 60? I'm going to rewrite this using 60. And that is on the unit circle. So I would go to my unit circle, pull the x coordinate and the y coordinate. And then the last part is to distribute the 1024. And because both of those fractions have a denominator of 2, and 1024 is even, this is going to end up coming to pretty numbers. So I would go to my calculator, 1024 times a half, it's 512. And then right here, we have root 3 over 2. Well, the root 3 is just going to tack on the end of it. The 2 would divide nicely into it, and we would still have 512. But we've got root 3, and then, of course, there's an I on the end. You try the next extra example. And you will be able to go all the way to a complex number. So this one's in radians. If that bothers you, change it to degrees. There's nothing wrong with that. In my math lab, you need to read the directions because it will tell you what format it wants, if it wants degrees or radians. But this particular example in radians actually works out nice because of the power being a 3. So let me walk you through it. So it's already in trig form. We don't have to find the trig format. And now we can go ahead and apply the formula. So the formula is the coefficient in front, r, to the power, parentheses, cosine, and then the power times theta. Notice how I've written that so that the power is lined up with the numerator of the radian times pi over 3. And I did it that way so that I can remember that the 3, that's the power, is understood to be over 1. And what happens right here with them? They cancel. And if you don't see that, when you go and multiply, you end up with 3 pi over 3, which is pi. So in this particular example, it would be easier to leave it in radians because it ends up coming out nicely. 2 to the third is what? 16? No. 2 squared is, 16, right? Hey, what's wrong with me? cosine is on the unit circle, so we can keep going and replace the cosine with the x and the y coordinate. Cosine pi. Pi is 180, so that's -1, 0. So the cosine would be -1, and the sine would be 0.